Morning, all of you. So far in logic, we have seen all standard tables, right?
Yes, ma'am.
Yes. Then we saw how to construct truth table for compound statements. Then we saw what is converse, inverse, contrapositive, right? So we will have one example quickly, a word problem of P implies Q form, okay? And then you will tell me the converse, inverse and contrapositive of that, okay? So let us have that. So consider the following conditional statement. All of you please write it down and you have to write the answer also in the words, okay? So P implies Q. If you do not send me an email, then I will go to sleep early. Okay, so this is your conditional statement. From this, you find out what is your P, what is your Q, and then one by one write down converse, inverse, and contrapositive. Do you understand the question? Girls, do you understand the question?
Yes, ma'am.
Yes, ma'am.
Okay, so what is P? What is P from this?
You do not send.
Not send.
Is it a compound statement? Is it a compound statement? Yes or no? Is it a compound statement? Answer my question. Girls, do you hear me?
Yes, ma'am.
So is it a compound statement? I'm asking you. Yes, no, we are using the connective if and then, right? From this, you have to find out the simple
Yes.
statements. You have to find out the propositions. There are two propositions which we have connected using the connective if then. Okay? The conditional connective if then. So, which proposition you will consider as P?
If you do not send me,
Don't use the connective while you consider the proposition. Okay, without the connective you will get the propositions. Okay, so this is your P, right? And this is your Q. In the proposition you will not write any connective. You understand that?
yes, ma'am.
So P
Yes,
is
ma'am.
U send me, you do not send me an email. You do not send me an email. Okay, this is your proposition P. And what is your Q? I will
Will go to sleep early.
I will
I will sleep early.
sleep early.
Go to sleep early.
Yes, and these two propositions you are connecting with the connective if then. Is that clear to you all? Now, what is converse? So, given statement is in which form? Given statement is P implies Q, right?
Yes.
Huh. So, what is converse then?
Q implies P.
Q implies P. So, how will you write it in words? Q implies P. If
If I will
go to
sleep
sleep
early,
early, then you
you do not send,
don't send
not
me an
send
email. Okay?
email.
Yes. Do you understand this? Are you writing it simultaneously?
Yes, ma'am.
What is inverse?
Negation P implies negation
Negation
Q.
P implies negation Q. Correct. Yes. So put it in words. If you, now this is you do not send me. So what will be its negation?
If you send me an email.
You
If you
send me,
send me, yeah, if
if
you
you send me,
send me an email, then now negation Q, then I will not
sleep,
go to sleep early.
sleep early.
Okay, this type of question can come for 2 marks. You will be given a word problem and you will be asked to write any of these three. Write converse, write inverse, write contrapositive. So first you have to write symbolically and then inverts. Now the third one, contrapositive. Symbolically, what is contrapositive?
Negation Q.
Negation Q.
Implies negation P, right? So what is negation Q? If I will not go to early, then you send me an email, right? Because your P is you do not send me an email. So negation P becomes you send me an email. Okay, so in the last lecture we saw what is a tautology, contradiction, contingency, okay? Contingency. Now today we will see logical equivalence, okay? Logical equivalence or logically equivalent statements. Okay, so you must have done little bit of this logically equivalent statements. Anybody can recall? Under this we have certain properties also, but first we will see what is the meaning of logically equivalent statements.
There are same truth value.
When you consider two compound statements, simple or compound statements, right? And you find that their corresponding truth values are same, then the two statements are said to be logically equivalent statements. Okay, two statements, simple or compound, simple or compound. Actually, they should be and or, huh? See how I'm writing, simple and or. इसका मतलब है both are simple or both are compound, or one is simple and other one is compound. Do you understand this?
Yes, ma'am.
हाँ. Corresponding truth values are same. Okay. For example, see, P is equivalent to negation of negation P. Very simple one I am considering. Very simple. This is P, then I will have negation P, then I will have negation of negation P. So what are the possible truth values for P? T and
TTFF.
T or F? No, 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 no. I'm just talking about one statement.
TTFF.
I am talking
Okay,
about
okay.
only single statement P. I am not talking about P and Q. P can be either true or false, right? So when you have
Yes,
only
ma'am.
one statement involved, you will have only two rows. Okay? Either the statement is true or it is false. When you have P and Q, you will have four permutations. So what will be negation P?
False, true.
False, true. And what will be negation of negation P?
True,
True.
false. True, false.
Understand this? This is true, false. This is true, false. Okay?
Yes.
So they are what happened. So see, these two are logically equivalent statements, and these statements help us to prove certain results. So this logically equivalent statements concept is important. Okay. For example, now we will have a very standard. This one is very standard result. P implies Q is logically equivalent to negation P or Q. Okay, we require this equivalence in proving certain results. Further, in proving validity of argument, etc. In checking validity of arguments. That's why this is a very, very important result. Huh? P implies Q is logically equivalent to negation P or Q. Hmm? So can we do this? Are you writing it with me?
Yes, ma'am.
So P and Q. Now there are two statements. So how many rows will be there?
P, Q. P implies Q.
Rows I am saying rows in the table.
Two.
टू आएंगे क्या? दो स्टेटमेंट से तो टू आएंगे ना अभी. फोर. टी टी एफ एफ, राइट? दिस इज टी एफ टी.
TF
Now we require what? We require negation P also, but
PM plus
make
PM
P
plus Q
then we require negation P, then
negation
we
Q.
require negation P or Q. Okay, so what is P implies Q?
TF T.
Right, it is false only when Q is false. Okay, now what is negation P, Anita?
FF
Girls, just a minute. Okay, so what is negation P?
FFTT
F F T T, yes.
TT
What is negation P or Q? You have to take this. ये
T
दो कॉलम्स का लेना है और कब फॉल्स होता है? Disjunction is false only when
FF
both are false. So this is T. Now in the
T
second row, this is
FF
false, this is false. So this is
T
false.
FF T T T T.
Right? आ गया समझ में?
Yes, ma'am.
Yes.
Now let us see. We want to see these two columns. So P implies Q and negation P or Q. Their corresponding truth values are same, है ना? Corresponding का मतलब क्या है? ये first row, second row. When you consider this standard form, this standard pattern, corresponding truth values are same. And therefore, P implies Q is logically equivalent to negation P or Q. Will you remember this result? This is a very, very standard and important result. Okay?
Yes, ma'am.
अभी देखो ये कौन सी फॉर्म में आता है, लिख के हो गया आपका फिनिश्ड मैम दिस वन?
Yes, ma'am.
अभी ये किस फॉर्म में आ सकता है? देखो जैसे कि मैं लिख रही हूँ P implies Q is equivalent to negation P or Q. So what would be negation of P implies Q? This will be negation of negation P or Q. Do you understand it?
Yes, ma'am.
Then here you have to apply De Morgan's laws. De Morgan's laws. What are De Morgan's laws? Anybody can recall De Morgan's laws? We are going to write down all of them, but you have already done these De Morgan's laws. Negation of P and Q is equivalent to negation P or negation Q. Negation of P or Q is equivalent to negation P and negation Q. तो यहाँ पे देखो negation of negation P और Q है. So this will be negation of negation P, or will become and negation Q, and this is P and negation Q. Are you getting it? Sometimes you may have to use this equivalence like this. Okay, so you should always remember this result. P implies Q is logically equivalent to negation P or Q. Yes. Now I am giving you one question. Will you do that? Prove that
Yes, ma'am.
Yes.
if and only if Q is equivalent to P implies Q and Q implies P. करो. 5 minutes है आपके पास. Okay? You have 5 minutes with you.
Done.
Ma'am.
Yes, girls.
Yes, ma'am.
हाँ,
Yes,
बोलो.
ma'am.
हो गया?
हाँ, ma'am.
Yes, ma'am.
Q. Then you require P implies Q. Q implies P, right? Or you have taken like this. First one this. अरे लेट क्यों ज्वाइन करते हैं रे? एक तो ध्यान नहीं रहता है शेयर स्क्रीन पे मेरा. हाँ. So P implies Q, then Q implies P, then P implies Q, and Q implies P. Yes, come on, girls. So first T T F F, then T F T F. Yes, bolo. P if and only if Q.
T F
T F F T.
F F
Yes.
T
Yes, when
F
both
T.
the truth values are same, then like this, okay? P implies Q.
T F T F T T T F T T.
F T T. What is Q implies P? अभी उल्टा है ये. Q implies
T
P.
T F F T.
Is
F
T
T T F T.
T.
F T.
Now conjunction of these two.
T F F T.
F F T. And now you
T.
see these truth values and these truth values. Okay. So corresponding truth values corresponding truth values in rough P if and only if Q and P implies Q and Q implies P are same. Therefore, P if and only if Q is equivalent to P implies Q implies P. Please unmute. There is some noise disturbance from somebody's place. Please mute. Yes. Have you understood this?
Yes, ma'am.
Yes,
Yes.
ma'am.
Also another important result. When you say P if and only if Q, it means if P then Q and if Q then P. That means the cases where the converse is also true. Okay. Now using these logical equivalences, we will see some important results. Okay. Some important rules of logic or properties. These are very important properties. So let us see those properties. The first one. So the title is Properties of Propositions. Okay. The first one, commutative properties. Sakshi Pawar left the meeting. I have to yet take the attendance. How people leave meeting in between? Commutative properties. Yes, anybody remembers what is, how many are there? 31. Okay. What do you mean by commutativity? Which mathematical
A plus
commutative?
P or Q.
No, I am asking in general. Commutative property means what?
A plus B is equal to B
Oh,
plus
yeah,
A.
2 plus
Yes,
1
A
is
plus
equal
B
to
is
3.
equal to B plus A. When you do 3 plus 4, it is same as 4 plus 3. So this addition operation is commutative. When you change order of the numbers, it doesn't affect the result. Okay, so basically it is A star B, star may be any operation, is B star A. So star may be addition. Is subtraction a commutative operation? A minus B is same as B minus A?
No.
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 3 minus 4 is not same as 4 minus 3, right? So we want to see these commutative operations, commutative property for and or. Okay, conjunction and disjunction. So the first one under this is A and B is equivalent to B and A. आप उसे किसी भी order में लिखो, they commute. Okay, A join B, sorry, not join. A or B. Let us not use the letters A and B. I'm so sorry.
P.
Yeah, because when we use that A, B, I talk in terms of Boolean algebra by default. Yeah, it is P and Q is equivalent to Q and P. P or Q is equivalent to Q or P. Okay, so we will check one quickly and whatever properties henceforth I am going to take, those you are going to do. Okay, so P, Q, then P and Q, Q and P. So T T, F F, T F, T F. P and Q is T F, T T, right? Nahi, no, it's wrong.
T.
What I have to write? T F F F, right? Conjunction is true only when both the statements, both the propositions are true. Now what happens to Q and P? Ulta socho abhi. Q and P. So Q and P means in this direction you will see T and T is T, right? It is true only when both are true. So Q is true and P is also true. So conjunction Q and P is true. FT it should be F. TF it should be F. FF it should be F. Do you understand this? So they are logically equivalent. Okay? So same for disjunction. Same for disjunction, okay? Finished or not? Girls, please mute yourself if you are not speaking. If you don't have any doubts, mute yourself. Have you finished it?
Yes,
Ma'am.
ma'am.
Yes, ma'am.
Next one. Associative properties. Associative properties. Yes. P or Q or R is equivalent to P or Q or R. P and Q and R is equivalent to P and Q and R. Okay? So we are just grouping them differently or pairing them differently. In the left hand side, we are pairing Q and R. On the RHS, we are pairing P and Q. Okay? Is it okay? So this is your homework. You need to verify. Okay? Check the logical equivalence using truth table. Next, distributive properties. Distributive properties. First one, P and Q or R is equivalent to P and Q or P and R. So you distribute P, okay, to both Q, R inside. P or Q and R will be P or Q and P or R. This is also your homework. Okay. Fast girls, I need to take attendance also. Idempotent properties. Idempotent means with itself. Okay. The properties of conjunction and disjunction with the statement itself. Sometimes you need to use it like that. Okay. P or P is equivalent to P. P and P is equivalent to P. Finished writing?
Yes, ma'am.
Because I'm going to the next last one. Now you have properties of negation. This we have seen already, the first one, that is very common. Negation of negation P is equivalent to P. Then just now we saw De Morgan's laws. Negation P and Q is equivalent to negation P or negation Q. Then negation P or Q is equivalent to negation P and negation Q. So this is your homework again. Okay. You have to prove all these logical equivalences. Okay, girls?
Yes, ma'am.
So let me quickly take the attendance now.